Everyone. We're still waiting for a few more attendees to log in, and then we'll be starting momentarily. Greetings, everyone. This is Don Larson, the CEO of Larson Software Technology. Welcome to today's webinar, CGM versus SVG. Before we get started, let me just give you a brief overview of the procedures and format that we'll be using today. Our presenter today will be Dave Manock, who has a background in technical illustration and is familiar with several technical illustration software and related software. The format that we'll be using for our webinar, which is typical of most webinars, is that we'll be, while we're conducting it, all participants will be muted. If you have any questions, you can see on the screen we're drawing your attention. You could use the questions in your webinar control panel. At the different points in the webinar, we're going to be using an interactive poll where you'll be able to vote on screen, and then we'll collect those results and present them back live. Your vote will be private, but we'll show the collective results for everybody in those polls. So on with the presentation. Again, our guest presenter for today is Dave Manock, who's going to. So we'll turn it over to Dave.
Okay, thank you, Don. Good morning, everybody, or good day, I should have said. That's just a brief biography of me, so I'm not going to labour on that at all. It'll be part of the slide pack when we send it out later today or tomorrow. So just like to thank Don and Larson for allowing me to speak today. It's a subject that's quite close to my heart and from experience. So this kind of presentation was prompted by some of the discussions I've seen on LinkedIn and things like that, and I probably want to try and allay some myths and give you some information today that you might find useful in your businesses. So obviously the title is CGM versus SVG. So firstly, CGM. It's an acronym, obviously, Computer Graphics Metafile, if you weren't aware. And it's an ISO standard, so it's got a long history from a format point of view, in a technology point of view, so back to 1987. And it's a standard for vector and composite vector and raster graphics. So as I said, it's got a long history. Scalable vector graphic, SVG, not quite as long. It was really primarily developed for the web, and it's a modularized language. It describes, again, 2D vector graphics, but also the same as a CGM, it can contain raster graphics as well. Probably the biggest difference is that SVG is XML encoded, so it's an XML standard as well. So I kind of prompt the presentation a bit at the bottom there by saying technical graphics and creative graphics. I think those are two kind of segments of graphics that probably most of them fall into at some point. Probably there'll be people out there that will disagree with that, but that's where I think mainly graphics fall into one of those two categories. So the objectives today. clearly to inform you a bit about the formats. Want to try and be clear and concise and try and minimize jargon, which is always a challenge, and try and explain some of the myths that surround the two formats. We also like to engage with you, so we've designed some polls that you can take part in, just to so it kind of gives you some interaction with us and with your other people that are actually involved today, so you can see the kind of audience that we've got. We'll also do a very short demo of the file formats, and it is short, so apologies if you're looking to see lots of demos of technology today. And we will record the questions and comments, and as I said at the beginning on Don's slide, is that we will probably record the questions and then respond accordingly. It's going to be difficult with the volume of people we've got on today to actually respond interactively during the session. And finally, want to try and enable you to make some informed decisions about your graphics. You know, what the best practices are, and do some analysis on your graphics production process. So that's the objectives. So for the content, we'll be looking at obviously the two graphics formats concerned, how they're governed, how they're developed, where they're being used, how they're being used, and how you originate them, how do you deliver them. We'll also probably cover some of the advantages and limitations of both formats, the benefits of the formats using them. They're both open formats, so immediately we have a non-proprietary format for both of them. Also interoperability, which is very important for some industries, and obviously we're conducting those polls that we mentioned earlier. So talking about the polls, we'll put them in at appropriate times. These are the questions we're going to ask, so don't try and make a note of them. They'll appear again when we get to that point. So it's very simple to actually, if you've not done it before, it's very easy to vote. It doesn't take long. You might just have to get the mouse or your trackpad ready just in case. So everything is private. They're not recorded. So what you see is on the screen that will be it. There's nothing which is recorded on your vote. So the first segment is to inform you. So just in brief about the two formats to begin with. They're both 2D graphics formats, as I said earlier. CGM has got the longer history for publishing quality graphics in different environments. So I wouldn't like to say how many years ago, but the web CGM profile of CGM was created for delivering on the web. So I'm trying to draw a comparison there with SVG, which was really designed for the web delivery. So CGM has a profile called Web CGM, which is designed to deliver to the web. SVG, that was its objective for a vector format on the web. And you can look more of the history in there. There's a link at the bottom which you'll be able to follow after presentation when we send the slides out, which is the secret origin of SVG. But basically there was different formats who were trying to become like the standard vector format for the web. And one of them was from Microsoft called VML, and the other was PGML, Precision Graphics Markup Language, which is very similar to Adobe's PostScript. But in the end, the final decision was to base SVG on XML. So SVG looked at these formats and decided to create it based on XML. That's a very, very brief history, but as I said, you can find more information there. Introduction to CGM, we've seen the acronym already. It's a 2D graphics format. It's not owned, it's non-proprietary, so it's not owned by a particular vendor. It's managed by the CGM Open Foundation at cgm.org, so I probably advise you to visit that site if you want to learn more in depth about the format and some of the technical aspects of it. It could also allow you to become part of CGM Open as well, so you can begin to steer and also develop the format as well. It first appeared in the 1980s, so as I said at the beginning, it is a pretty old format, but I still believe it is a modern format. It's because it's really widely supported by many graphics applications still today. In the beginning, it was supported by virtually everything. Today, it's probably more of a select band of software that supports it. The web CGM profile was developed specifically for the web, but at the same time is adopted by the S1000D specification. So if you're not aware, that is a military standard for technical publications. You can find more information on that at s1000d.org. One thing to talk about from CGM from a web delivery, though, is it does require a plug-in technology to deliver the files, say, in a web browser. So as you see, that becomes more relevant as we go along, particularly in the next slide with SVG. So a quick introduction to SVG, scalable vector graphic. It's XML encoded format, so that's an attractive thing. It's a structured format, so and is open, obviously, as CGM is. It's a W3C standard, so you can find more information about the format there. W3C is the organization that overlooks standards on the web, so there's a lot of information on that particular site, but one of the components of that site is SVG, and also Web CGM is on there as well. It's again managed by a consortium of people. It's not owned by any particular vendor, so if you want to contribute to the SVG working group, then you want to visit that page and apply, then you can become part of that group as well. One of the key differences, though, from CGM is that SVG is native to the browser, all the popular browsers, so Chrome, Internet Explorer, Firefox, Safari. You can just drag and drop an SVG file onto that browser and it will open automatically. So it's HTML5 native, something that CGM isn't at the moment. So this is not particularly scientific, but just to give you a comparison to begin with, you can see on the top right, well, it's not that, it's a bit blurry, but you can see it's an XML file. So this is looking at the source of this particular file on the left. Just a simple exploded view, a technical graphic really. And on the left we have or lower left we have the encoding for the CGM file, which is not XML. Probably wouldn't advise you try and code this or change this at all. So, but the main difference here is the file size. So just a quick warning to begin with, that with SVG your file sizes are substantially larger. So that you have to take that into account when you're delivering the file, but also storing the file as well. So at this point we're going to do our first poll. I'm just going to set this up, so just bear with me a second. And I'm going to launch the poll now, so it'll appear on your screen, and just fire away and choose. You've got multiple answers you can choose. And hit submit, and we should begin to get some feedback from the audience. For this first one, I'll just leave it running a few seconds. We've got 53% of the people voted, 65. So I haven't got anything prepared to actually comment on when I get the results through, so it's pretty much going to be off the cuff. Got 83% voted, so I'm going to, well, we're still going up. Obviously people searching for their mice at this point. Okay, 91%. Okay, I think I'm going to close it at that point. That was a good, thank you very much for that. So I'm going to close, and then we're going to share that with you. So we've got a fair amount on the CGM side today, 88%, 33% SVG, which is good. Close behind we have EPS and then Adobe Illustrator, so predominantly CGM people on the line, but others are 60 as well, so that's an interesting statistic. So I really thank you for participating, and we'll move on and we'll do another poll later on in the session. So firstly, I just want to cover it in more detail, the CGM file format. What I've tried to do is kind of split this into, again, categories. So, and then do the same thing with SVG, so we get some kind of comparison. So firstly, maintenance, CGM. It's very accomplished at maintaining complex technical graphics and output into multiple publishing formats. I don't think there's any dispute about that. The technology that surrounds CGM really has to have the ability to create and retain the CGM files in a consistent and structured way and format retained. So that is important if we're going to interchange files, because data exchange is key to the CGM format. It needs to go out to perhaps to third parties and suppliers, so it needs to be interoperable. That's one of the main requirements of the format, which it does. We also need to deploy the file, and so we need to get that file to print and also to the web, and we need to do that consistently and with interactivity as well as a rule. So there's they might have no interactivity, but if there is a requirement, say in a spare parts environment, then it needs to be interactive. And finally, the advanced section is that the industry, there's industry profiles that can be used to validate files. So if you think of, say, the aerospace industry, it's important that the CGM is consistent across suppliers and OEMs. So profiles are very important, and CGM supports that. And finally, something that probably not a lot of people are aware of is that there's a DOM, or a document object model. That's as technical as I'm going to get today, which really provides the mechanism to manipulate the files. So probably one of the myths is that CGM can't be animated, but it can through the DOM. So that's probably one of the myths that we'll dispel today. So now we'll look at those in a bit more detail, each of those sections. So the CGM properties, the maintenance, the graphical attributes, usually these files are used for long life cycles, so we really need to be able to retain that structure and the structure of, say, of ellipses and circles and vesicles. We don't want to break these down into polylines and so forth and lose their ability to edit them. They also have to communicate a technical message, usually in black and white. I think that is still probably true with the majority of technical graphics, although it could be changing now. So it's quite a low level of creativity, but, well, not creativity, but a low level of graphic representation we need. Text attributes, again, probably a low level of text. We don't need to do a lot of text manipulation. Usually it's just, it might be just a call out, and it would probably only be Helvetica or Arial as a text, as the font. So quite low levels of text required. And the ability to constrain text is important. So CGM does allow you to constrain text within a certain area because you don't want that overlapping the graphical area that could be important to the user. And also metadata is obviously an important part, and as the file format name implies, it needs to support metadata, which could be hotspots and so forth, and also an ID of a part or information about the part. The other thing that's probably not, some people aren't aware of, is you can have an XML companion file for the CGM, so you could actually contain metadata outside of the CGM itself. So you could have an XML companion file to the CGM. So what about the technology? I'll apologize if I've missed people off here and who might be on the webinar today, but this is why my take on probably the most companies at the forefront of CGM technology from a creation and origination point of view. So it's important these tools that obviously support all the CGM profiles, and that also obviously good at creating graphics, which is obviously primarily a requirement. So some of you might recognize some of the names, some of you might be using some of the software that we detail here, but all of them support CGM. The Vizualsite edit from Larson actually works natively in CGM. Isodraw has a mode that allows you to work in native CGM. So the others really would more reliant on exporting the files out from the proprietary format to a CGM export. So that's probably the main differences there. So reliable. It does have to be reliable. It needs to be interoperable. It's got really good data exchange capabilities. It conforms to profiles set down by the S1000D and the commercial aerospace standard, the ATA iSpec 2200, which really makes these files easy to interchange and interoperable. One thing is that what you don't need is, if the files are not interoperable, then program costs can actually increase. So we have to be careful of that. Also, there needs to be good usability and reusability of the files, which goes back to actually retaining those graphical attributes. And also the file needs to be considered that it's got a long life cycle. So many of the graphics in the technical graphics area have to be maintained for many years. So an aircraft might be a good example where there's lots of graphics created and have to be maintained for many years. Say the 747, for example. So deployment. Obviously, we need to create the graphics, but we also need to distribute them or deploy them into different environments. So primarily the web or IETMs, Interactive Electronic Technical Manuals, is a way of deploying technical graphics today. There are again some technologies here that allow you to do that, because, as I said at the very beginning, you need a plug-in technology to distribute on the web. So there's some technologies here, you've probably heard of them, like IsoView and VizXView, Cortona's 2D Viewer, MetaWeb. So there are others out there as well. I didn't have really time to go through all of them, but I think those are the prime ones that are being used on the market today. And there's also the, obviously traditional print still has to be catered for, so not everything goes primarily or exclusively out onto the web or electronically. So we still need to publish CGM as part of a manual, or in most of the software I just mentioned back in the creation software, you can print out individual files, but you still have to put them as part of the manual. So there's some technologies here that allow you to obviously merge the text and graphics into, say, a PDF deliverable, or just to go to, obviously, to print. And I won't go through all of them there. There's quite a few different ones available. We're all doing the same. All the output is going to be the same. It's just how you get there is going to be different using the different technologies you see here. So the final section, CGM, is advanced, and I think it is an advanced format. It's the actual the profiles themselves allow this compliance to industry specifications, which I would consider an advanced concept. So if you think of the profiles as rules that the graphic could be measured against, so we can then validate them against these different specifications, which is quite a powerful thing to be able to do if you want to have a consistent archive of files. The other thing is that these profiles can actually cascade, so you can layer them one on top of the other. So we have CGM, the ISO standard at the base there, and layered on top of that is obviously a model profile and web CGM profile, and then we get to the S1000D profile, so which is more a set of business rules that we then have a complete file that we can validate against for that particular specification, which is a powerful thing to be able to do. So we have to, there's a few tools out there to do validation as well as the CGM. So you probably compare this to like parsing your XML data, your text data against, say, a schema. So it is possible, because of the structure of the file and the profiles of the CGM, to actually check against those particular specifications. So there's some software there from different vendors that allow you to do that. We also have the web CGM DOM, as well, as I mentioned, that kind of gets forgotten about, but does allow you to manipulate the CGM. So animation is the favorite kind of topic, but it could allow you to turn on and off layers and so forth, to really control the CGM to provide the user with a more interactive environment. And obviously there is an XML kind of connection with the XML companion files as well. So at this point I'm going to do this very short demonstration. I'm just going to click on the link down here. And we're in Internet Explorer. So the first thing we need to kind of note at this point is that we are in a plugin technology to see this CGM. So we have some controls at the top here. We can zoom in and zoom out. We can select the area we want to zoom in and then we can zoom out. So pretty simple controls. We can print and we can save. So we do have this toolbox. So this is the benefit of having the plugin, that we do get this toolbox, and there is some animation. It's not sophisticated, so that please don't laugh at that particular animation, but it does show you that the CGM can have animation in it if you control it through the DOM. So that's our first kind of demo of CGM in a web environment. Some additional resources. So I'm hoping, like I say, there's a lot of information I'm giving out today, and you will get the slides, so all these links will work and you can visit all these places when you have time. So we have NIST, so this is one of the controllers of the format, or one of the original controllers of the format, along with ISO, and then we have W3C, and we also have some groups on LinkedIn that you might want to participate in as well. So lots of information there and resources to go out to. Okay, so we'll come to our second poll. I think you all know the procedure by now. So I'm just going to launch this and let you participate. So up to 61%. Obviously it's a lot faster than last time. We've all got to grips with this now. We've got 76% voted at the moment. We'll give it a few more seconds if that's all we have. Obviously some of you might not actually have any graphics to maintain that you might have in other parts of the business sphere. Okay, we're up to 78. I'm going to actually close it at that point. Thank you again. And I'm going to share that with you. So, predominantly we've got people on the line today that have to maintain graphics for over 10 years, which is a substantial amount of time. So I'm thinking we've got a lot of people in the military and aerospace industry on the line today. Thank you again for that, and we'll move on from there. We only have one more to go, so thanks for your participation so far. So let's move on to SVG. We'll do a similar thing here as we did with CGM, and hopefully you'll begin to see the differences between the formats. So maintenance of SVG, it's XML encoded. It's, again, capable of high quality display and print output of creative graphics. So I'm creating a distinction here that SVG, I feel, is more for creative graphics. The technology needs the ability to create compelling graphics for web distribution, so animation and so forth. You can see when we go into reliable that we want something that can do fine color control, typographical effects. The filters can be applied to raster images, including transparency, interactive and animated graphics. So a bit of a different kind of vibe to the CGM. Deploy is quite simple, native HTML5. You can still print traditionally, but I think primarily it's going to be a web format. It also has this DOM that you can control the SVG file, and it also has a document type definition. Sorry, I think we have somebody on the line. Okay. So sorry about that. So we have the document type definition, which can actually be built up as a profile. So if you're, if we go back to the CGM, then you think we have the profiles there, then equivalent could be, we could have the equivalent on the SVG side, but to my knowledge at the moment, nobody's actually doing that. So maintenance, graphical attributes. It needs to be easy to maintain, and it is in its original and proprietary formats. You need to have excellent control over the graphical objects, because we're doing something quite creative here. So also typefaces are very important. They can be controlled by cascading style sheets. So this is obviously very important if we're going onto the web and we want full control over the graphic attributes. And sorry, the text attributes.
Dave, if I could interrupt just a moment, your PowerPoint is not showing. We still have the poll up.
Apologies. Thank you, Don. Apologies for that, everybody. Not run a poll before, so that's we just went through the. I'll just go back a slide. We just went through this here, so you heard me speaking about it. So this slide will be part of the pack. And graphical attributes. We went through that, and text attributes, and finally metadata. So SVG does support metadata as does CGM. But it's pretty open and flexible. There's an encouragement to use metadata standards, but it is pretty open what you do. So the technology. There's a whole long list of software that can support SVG, mainly in an export mode. So I couldn't list them all here. It'd be impossible. So I just wanted to show you a few that you're probably familiar with. They do obviously, most of them would have comply with exporting the file out to an SVG format. There are a couple of native editors that you might want to look at. One is Inkscape, which is a desktop application, and the other is SVG Edit, which is more of a cloud-based, web-based application. And then you have the usual graphic software. Adobe Illustrator supports it, obviously SVG, and also Corel and Larson Products with Edit. But we could go on from there. A lot of software nowadays does support SVG. And then we have animation. So we do have the products out there that support the animation of SVG files. Specifically, like Adobe, again, have a product for that, and also there's a cloud-based product called Animatron. And then we have some libraries of JavaScript for SVG that allow you to do the controls I was talking about in the DOM, so fully control the file when we deploy it. So a lot of technology out there around SVG as well. So we'll go to reliable, and this is where I think this is the big difference between the two formats, is interoperability. I think this is a real weakness of SVG. I would not advise you interchange the SVG format, because there's no doubt there will be losses of data. So the integrity of the files could be lost. So this is not good if you're in an environment, a technical graphics environment. So revisions are best performed in the original proprietary format and then re-exported as SVG. So I would say that the format is suitable for short-term objectives, short-term jobs, and it's definitely wouldn't use it as a graphics archive. I think CGM is capable of that because it's good interchange capabilities, but certainly not SVG. So the deployment of SVG, well, it is really convenient. HTML5 native, no plugin required, supporting all major browsers, very, very good quality, animation of graphical objects, very, very flexible, easy to use. But the limitations, because there's no plugin, then we don't really get the control over the graphic we had earlier. So a lot of the controls of the graphic will probably be needed to will need to be added in by the creator of the file. So that is a bit of a limitation and a disadvantage of not having a plugin. So let's launch the file. So I hope you can see that. I tried to choose something that's technical in nature, and you can see as I click on this, I'm using just the mouse to click, then we actually start to explode the file, and we can see some hidden details. So it's quite a nice example of what you can do in SVG, but the control I have is basically through me clicking. There's no toolbox or to enable me to do anything else, so that would have to be enabled in some way. Also, if I look at the page source, you can see, although it looks a kind of a straightforward graphic, then we can see that this is quite a large file. In fact, if I scroll to the bottom, there's actually 2,628 lines in this particular file. So probably not that scientific, but it shows you the size of the XML file that you can go to. So we've got to be wary of that when we're delivering files. So advanced, it is an advanced format, I would say. It's got a document object model, so we can have full control over the SVG, including style sheets and animation and so forth. It does have a document type definition, so in theory somebody could write a profile or a schema for the industries such as S1000D and ATA. So it is possible, if somebody's got the appetite to do it, to create something that would provide rules for SVG. It's cascading style sheets, very powerful for styling the graphics and the text. And then, as I said, animation. It's a lot you can do: fade in, fade out, objects grow, shrink, spin, change color. Anything you want to do really creatively is there. And again, some additional resources. Adobe was probably one of the pioneers of SVG, so they still have their developer center, although if you're looking for they used to do an SVG plugin, but I think you can still get it, but it's not supported by Adobe anymore. Some other resources, but there are lots and lots out there for SVG. Because it's part of, obviously, the web, then you can find a lot of information about it. These are just some. And there's also on LinkedIn, again, an SVG group that you could join. And the final poll, and this time I'll try and do it properly. So thanks for all the people who are still with us, and I'm going to launch that now, and I won't forget to hide it this time. Very simple one. Do your graphics require interactivity? I think probably the majority of people will say they do, although I could be proved wrong. So we've got 84% of people voted, so thank you again for participating. And it looks like we're at the end, so I'm going to close that down, share that with you. So predominantly people are using hotspots, and a high percentage of animation, which is really good to hear, and non-required, probably at the low end. So good to hear that people are now supplying interactive graphics. That's a really good thing, because that's where the value gets to the customer, when they can interact with the file rather than just seeing a graphic static on page. So that's really good. And we're going to hide it this time. So sorry about last time. So the final part is enable, and I'm hoping that I have enabled you to do some analysis today on your graphics. So perhaps you could analyze your current graphic archive. What file formats are your graphics held in? Are they proprietary, non-proprietary? Are they raster, are they vector? Do you need to look at an alternative open format, perhaps? Storage and display. File size. Not as critical as it used to be, but still quite important when you're actually displaying files. Storage probably less of an issue nowadays, but actually displaying them, still a factor if you want to display them in an interactive or a web environment. Management, probably not an area that is too concerned with the illustrations, but I think it's an important one, because the textual side is really managed quite quite well, with the different databases, but perhaps on the illustration side, not as much so. So perhaps you want to look at how you're managing your graphics and could it be done more effectively. Compliance. From the audience, from the feedback from the audience today, I probably think most of you are trying to comply to your technical graphic specifications. So perhaps you might want to think about validating them against those specifications. It's just an idea. Quality control, the same thing. Validation does give you a better quality control and hopefully makes the delivery to the customer easier and cheaper. Open graphics formats. If you're not using one, perhaps you need to consider migrating to one. I think it would be more sensible to base your archive on an open format than a proprietary one. So hopefully you can make an informed decision about migrating your graphics. So if you are going to migrate them, these are probably some of the headlines that you need to think about. What open format are we going to choose? What's the business case, the benefits, the cost to do it, the return of doing it, and also what conversion process might we use? It might be on an ad hoc basis or a complete batch process. So, and what software tools are going to be required to perform that task as well. So really briefly, to sum up the presentation, I think I've been quite clear on where I stand on the two formats. I'm not sure it is as much as a competition as you could use both of them. It depends on the use case. That's my opinion, that what you're going to use your graphics for will probably determine what format you choose. The good thing is they're both open formats. So in that case then, your data is protected. So from a technical graphics point of view, I would probably recommend CGM. Certainly can aid you in long life cycle requirements. It's got a good stability through the ISO spec. Production, there's lots of software out there, and it's easy interoperable between between different the supplier and the customer. Also, we've got the industry profiles that allow us to do the validation, and also it retains the integrity of the file, which is pretty key in the industries of military and also aerospace. So SVG, fantastic for creative graphics, easy deployment, couldn't be easier, especially on the web. Production requires flexibility and creativity, so probably not as much so in the technical graphics world. It's more about interchange and making the illustration clear, so a bit different requirements. But I would say my final thing, and not to be end on a negative, but I would say be careful when interchanging SVG files because there could be losses of data that could occur. So just need to be kind of wary of those things. And so at that point, I'd like to thank you for your attention today. Thank you very much for participating in the polls. That was fantastic. And also thanks again to the audience with respect to staying with us. It might have been overrun slightly, but hopefully you've got the information you require. So at this point, I'm going to pass you back to Don just to close the session.
Yeah, thank you, Dave. That was for that very excellent presentation, comprehensive. So yes, well done. For all of you, we're going to be we'll put together a slide pack after this webinar and a recording, which we'll send to you all, and then we will be posting on our website too, under our news and events page, so you could pick it up there too. And again, we'll address. I see there's been a couple of questions and comments, and we'll address those too. This has been a Larson informational webinar. There will be more to follow. The next one we plan to do in May. The next Larson product webinar will be in April, where we'll do a product demonstration of our new version of VisXedit. So thank you all for attending, and so we're going to this concludes this webinar.